Welcome to the University of Gates and Controls training series. This video is part 1 of the 5 food groups of automatic gates. Brought to you by the University of Gates and Controls. I'm Sean Tomlinson. In the 5 food groups, we start off with group 1, which is gate type. Here we'll talk about swing gates, slide gates, various layouts, and different configurations. In group 2, we'll talk about the gate operators that go with those types of gates. We'll talk about gate operator capacity and different kinds of design elements. In group 3, we concentrate on gate safety, UL 325 and ASTM F2200. This is a big impact on how we design gates, install them, fabricate, and entrapment sensors. Group 4 are accessories and access controls. These are all the devices, keypads, card readers, the things that we use to tell gates to operate and open and close. And in group 5, we'll talk about vehicle detection. We'll talk about inductive loops and other types of sensors. And in later videos, in addition to gate safety, gate types, gate operators, we'll also talk about electrical power, vehicle detection, low voltage wiring, access controls, and gate hardware. The first food group of gate automation is the gate itself. Everything else comes after. There are many kinds of gate systems and an infinite number of ways to configure them. The use of one versus another is dependent on the customer's needs and the physical space arrangements available. Residential customers might prefer a swing gate because of the way that it looks nice or simple to build, whereas in a commercial application, a slide gate may be preferred for its inherent security and durability. Of course, the layout of the site and the restrictions for room to the sides, for slides or swings, all are taken into account, of course, when you preview the job and visit the customer. Application, application, application. Again, use the right equipment for the job and the job will go right. So once you've done your preview, you'll understand the elements and the customer needs. Poor gate location and layout can cause traffic problems and poor performance. The intended use of the system will determine the equipment needed. So gate types. Different applications have different needs. Residential, commercial, industrial. These are the 3 major groups of different applications. Some important factors of gate design, of course, is the gate size. This will be determined by the customer's needs and the site location. But it's also important to understand that the size and weight of the gate can impact the type of operator you might need, the materials, the construction methods. A light gate used in a high cycle application may need a commercial rated gate operator. Gate weight, of course, is driven by the materials used, but also will impact other things like hinges or wheels and support posts and wall thickness of materials. So all of these things must be taken into careful consideration to build the best possible gate system. The gate construction, will there be any wind drag problems? Are there any UL and ASTM applications? We'll have more on that when we do cover the ASTM and UL section. And operator attachment, that is a very important element, and we'll talk more about that as we go. Let's talk about swing gates now. So swing gates are typically found in residential applications, although they can certainly be used in commercial applications. But more for private homes, gated communities. They look nice, they're beautiful, they're easy to attach to hinge posts, can have a simple look of tube steel or chain link material, but of course they can be very elaborate design with scrolls and forgings and other decorative elements. A strong, well-supported hinge post or pillar is needed to support the hinging and weight of the gate, so that's a crucial element. And that's going to in fact impact concrete footings and soil conditions and things of that nature. Swing gates can be configured as single swing. This is where there's only one gate leaf or gate panel used, or they can be dual leaves or 2 gate panels, which we refer to as biparting, where both gate leaves are moving and opening and closing in tandem. It's important to note that a swing gate is more susceptible to wind and forced entry. Think of it, a swing gate as a big long lever. So compared to a slide gate, due to that leverage, a lot of force can be applied to it, whether it's someone trying to force the gate open, or a car or vehicle tagging or hitting the gate, or even wind can do things like that, damage to it. In the case of a single leaf gate, additional security can be achieved by incorporating a lock assembly such as a mag lock or a solenoid lock into the catch post. However, using a lock mechanism on a double swing gate is much more difficult and requires a lot more planning and design. The alignment of two gate leaves for a mag lock or a solenoid lock has to be very precise and very predictable. Regardless of the material used, most important is to make sure that the gate frame is rigid and can support its own weight in addition to the forces from wind, forced entry, and the operation of the gate operator.
So gate type, layout, swing gates. So let's talk a little bit about hinge post and hinge pillars. Very common method of hinging a swing gate, especially in a residential application, is to hinge it off of a brick column, brick, CMU, block, rock, concrete, a variety of materials. And these all look nice, and that allows you to hide the hinge post and things like that inside of the hinge, inside the pillar, as you can see here in this illustration. But due to an ASTM concern and a safety concern, when you hinge that gate off the center of the pillar, you create a entrapment zone here that I've shaded in here. And so that poses a safety problem. So to mitigate that, you want to design your system so that the hinge is in the corner. So it's not in the center of the pillar, it's off to the corner. In fact, ASTM says that the maximum of 4-inch overlap between the corner of the column here and the hinge, that minimizes this entrapment point. So that doesn't mean you can't put it onto a column or a brick pillar. It just means that you need to have your hinge attachments points near the corner and not in the center. Remember, a swing gate, they're like big levers, and gate operators attached to them have tremendous amount of torque that can be applied near the hinge point. Okay, testing, 1, 2, 3. Do you see my mouse here on this right here? So here we have an illustration of a single swing gate. Operators on the left-hand side, because remember, from the inside looking out is our handing, and access control pedestal on a pedestal on the left-hand side coming in, on the left side, drive side coming in. Here we have an illustration of a double swing gate, pad mount operators. Notice our inbound traffic pulls up to the pedestal. One thing to keep in mind is that this can create a head-on traffic issue. Now, for a low volume residential, this is a very common application to have this occur. However, in a high volume situation, you might want to have a dedicated entry lane versus a dedicated exit lane. Here we have an illustration of a double swing gate pad mount with pad mount operators, and we have columns, and you'll notice that the columns have the hinging in the corner and not in the center, like we talked about before. In this illustration, just another one of a double swing with linear actuator type operators, more of a residential. I'm also indicating loops here, but since we haven't talked about those, I won't spend too much time on that. One thing about actuator operators is they typically have a remote control panel, as you can see here, and that can be located wherever convenient, on the left side, on the right side. It can be mounted to a fence line or on its own post, or maybe recessed into a block column. So here we have a swing gate illustration, multiple pickets, some horizontal elements. Again, you always want to consider the construction of the gate as to where will you attach the operator, what's the strongest part so it doesn't bend and break and things like that. Swing gates, of course, can come in single panel and dual panel, or single leaf, double leaf. Here's a picture, of course, of a very nice double leaf swing gates. One of the most common mistakes in a building swing gates, like I've mentioned before, is building a strong attachment point for the gate arm to attach to. You can see in this illustration here where the pickets have actually been bent, even though there's a metal bar or a strap attached to several pickets. This gate still probably might have got hit, might have got force, but not enough to completely damage the gate, but enough to bend these pickets. So really the proper way to do this would be to have a completely horizontal bar that the arm attachment can be made to, and so that has to be incorporated into the design of the gate. Remember, a swing gate is a big lever. The longer the gate, the more leverage. So here's an illustration, kind of a shop drawing layout plan. The point here is that every make and model of operator has slightly different dimensions, maybe its height, the placement, the geometry, the setback. All these things have to be taken into consideration when choosing the model of operator, which we'll talk more about in the next chapter, but it also impacts the gate design and the layout of the site. Is there room for that pad mount operator to fit in the location that it's going to be in? Does the arm, as it opens up, happen to open up against a block wall or an entrapment or maybe even to a walkway? Slide gates. So these are more utilitarian, more common on commercial industrial applications, although they can certainly be in residential applications. Slide gates offer more security and durability because of the way that they operate, but at the same time they pose a greater risk of personal injury. More serious injuries are due to slide gate accidents than swing gates, although they do occur on both. Slide gates require special hardware to support and track or guide the gate while opening and closing. We categorize slide gates into two major groups: roll gates, would be a type 1, typical of a V-track or perhaps an overhead trolley style gate, and then cantilever gates, which are certainly type 2 and becoming more and more popular. Here we have an illustration of a double sliding gate. So I have two biparting slide gates, and we have a turnaround access. So as you can see here, I've got room for a guest or delivery truck to pull up and use the intercom and not be blocking the traffic flow that's going through. So of course that truck could pass through and then back into traffic. So these are things that you want to consider in your different layouts and different applications, of course. Here is another illustration of a double sliding gate system. Here's a single slide gate with the gate operator on the left-hand side. Since our access controls are on the driver's side, still need to consider conduits and trenching across the driveway and wiring for photo eyes and things like that. So talking about V-track or type 1 systems, let's talk about the V-groove wheel and the V-groove track. So here in this illustration, I'm showing a 4-inch V-groove wheel. 4-inch and 6-inch are the most common sizes in our industry, and it rides on an inverted angle iron here. And up here you can see an illustration where here's the angle iron that the V-groove wheel is riding on. And this is what tracks or guides the gate back and forth. Without it, the end of the gate would just wander across the driveway and it would never reach the catch post and wouldn't work very well at all. Here's an illustration and a picture of an actual piece of V-track. You'll notice that it's pretty scarred up. That's due to a lot of maybe vehicle hitches, maybe low slung hitches and trailers, or maybe forklifts or a variety of things. So although V-tracks are very popular in the West Coast, they're quick and easy to make, they do have their drawbacks. This is also a very poor job of installation. They didn't even weld these two tracks together, and so that's going to create a big bump there, and not very good. So looking at our V-track guide system, here's an illustration of our slide gate opening up, and it's guided by the V-track. You'll notice that our track has to cover the width of the opening, also an equal distance into the stacking area in the back. because we need to have enough track for both wheels and the whole gate to travel back and forth with. Now the wheels do not need to be on the very end, and that allows us to keep the track a few feet shorter. So here, my general rule is about 20%. I like to pull these wheels back in from the end about 20% of the length of the opening. That helps balance the weight of the gate over the wheels. If you go too far, the gate can start to teeter a little bit, but this is a pretty good method. The other part of a V-track system is the upper guide wheel system. Obviously, the V-track down below guides the gate back and forth in a straight line, but we still need to stabilize the gate from just falling over, and that would be through our guide wheels. This illustration shows some section views of a V-track slide gate system, one on the left here with a upper guide wheel system. We got 2 wheels on each side, and this one over here shows a double post system. So here's kind of a picture of your guide wheel. Many different makes and models of guide wheels. The idea is you find something that you can mount adequately, has covers, that's a UL standard issue, and then works for your application. So in this illustration, I'm showing a plan view of the gate operator, the gate panel, and it's guiding through the 2 guide wheels here. Here's our support post and maybe an adjacent fence line. What I want to point out here is there's a large gap between these 2 points here, and when we talk more about ASTM and UL, you'll be familiar with the requirements for spacings in automatic gates. And in this case, we want to minimize that gap between a fixed post, which is the guide post here, and the moving gate panel to a maximum of 2 1/4 inches. So the way that this guide wheel is placed here, it's placing the gate more than 2 1/4 inches away from the post. So that leaves for a large gap. An alternative is to design your guide wheel assembly so that it doesn't have to push the gate panel away so far. In this illustration, I've put the guide wheels on the back side of the post, and that allowed me to keep this gap between the guide post and the gate at the 2 1/4 inches. It's much preferred and much safer. Here is a picture of a box frame gate where it has 2 gate frames that are separated and connected by a box frame assembly, and it has 2 V-track guide rails. Not a very common method, but it is something that's employed for much longer, larger gates that need to have more stability to them, and so a box frame is preferred. So next we'll talk about cantilever gates. There are 3 kinds of cantilever gates. Cantilever gates are classified as type 2 versus a type 1, which was the rolling gate or the V-track gate, which is a type 1. So now we're into type 2 gates, and they have class 1, class 2. Class 2 has an upper track assembly design, and then there are class 2s that have a lower track design. So in this first illustration here, you can see that this is a class 1, and it's indicative of the 4 rollers in the 4 corners. This is a picture of the rollers here that hold the weight of this gate and allow the gate panel itself to be cantilevered out. These are typically easier to shop build. They're easier to do at custom lengths and sizes, but for longer, bigger gates, the class 2 designs are preferred. Over here, this is our class 2 with an upper track assembly. So there's an extruded aluminum material built into the gate. Usually these gates are not so easily to be shop built. They're usually manufacturer built and bought to spec. Here you can see the upper trolleys, and they're carrying the load of the gate. And there's a trolley assembly up at the top here and a trolley assembly here. Down below is just a set of guide wheels to guide the bottom of the gate. The second class 2 style, same principle, but it has the trolleys down on the ground, down lower. So here's a picture of a trolley here, and the guide wheel at the top. This kind of material can be shop built because of the way this material can be bought. So it's another good example of a cantilever gate system. So here we see an illustration of a Type 2 Class 1 cantilever gate. You can see that we have our 4 cantilever rollers. You can imagine that when the gate is in the fully closed position, the weight of the gate is going to put all the weight on this lower wheel here and this upper wheel here. Only 2 wheels are carrying the load when the gate is fully closed. When the gate is fully open, then the opposite occurs. The weight is on this lower wheel and this upper wheel. So again, here is our illustration of our cantilever gate, and as you can see, as it slides back and forth, you can imagine that weight distribution changes from the 2 different sets of rollers. Now, here I'm illustrating that if the wheels are not adjusted right, if this wheel is just a little too high, you can imagine that the gate is going to droop or drop down. And then as the gate goes the other way. So irregularities in the construction of the gate, irregularities in the alignment of the wheels are crucial to making one of these kind of gate systems run properly. Otherwise, you're going to have that dropping and drooping element. Here's an example of a cantilever gate. This is a very wide opening. It's a box frame like I mentioned before, and you can see that box frame here. This gate here has very wide box frame construction, all aluminum, it's completely cantilevered, nothing is touching the bottom of the ground. Here's a good blow up of a Type 2 Class 2. This is the lower track and trolley assembly. So this large tube steel here is specially rolled and fabricated so that it fits this trolley assembly here and carries the weight of the gate. And takes 2 of these, one up here and then one in the back. Now here's a picture of a cantilever gate, but it doesn't have to be a straight, boring chain link style gate. It can be curved top, it can be ornamental. In fact, is due to the fact that the trolleys are down below, all you have to do is have a guide wheel that maybe rides on a horizontal piece like right here, and you can still have this upper curved piece thread through. Here is another plan view, just a variety of different methods of having upper guides. Here's a double post guide. Notice this is kind of notched so that the chain can thread through. Okay. V-track, this one down here happens to be a V-track as opposed to cantilevered. A good plan and a good shop drawing will help everyone be on the right page. Here's an example of a Class 2 cantilever that has the extruded aluminum material up at the top. This one happens to be called a double track. You can see there's 2 on each side. So there's a truck here and a truck here. There's also a truck in the back here and on the other side as well. Down below is a set of guide wheels that guide the bottom. Vertical lift gates. So these are very rare but yet very unique. This is a unit made by High Security called the Hydrolift, and you can see that there are 2 towers here, one on each side, and this gate panel, which is supplied by others, is raised vertically up and down. So we call it a vertical lift gate, not to be confused with a vertical pivot gate, which often people do, and we'll cover that later. Vertical lift gates have a minimum or maximum height requirement. So you can only get these for about a 14-foot clearance. That requires these towers alone to be about 24 feet high. The width of the panel can be up to 80 feet with the right model of operators. Now you do want to consider wind loads. When that panel is up there in the air and you have a lot of wind or gusts of wind, the footings and the concrete down below need to be substantial, often requiring the use of a engineer or a soils engineer to verify the footing size given the kind of soils and the kind of wind areas. Inside the tower are baskets that have counterweights, so they balance the weight of the gate with a balance of counterweights down in the towers. So that's how you can actually make these so that they are very neutral in weight, and you can manually lift them if there's a system failure. Here is an example of a vertical lift in a residential application. So beautiful wood-cladded gate panel here, some nice cultured stone or real stone, whichever here, these beautiful columns. And then notice the towers here are actually cladded and hidden inside of a wood pole or tree, if you will, and that's pretty cool looking design. And that goes with the architecture of this log cabin back here. Vertical pivot gates. So not to be confused with a vertical lift gate. Even though it looks like it lifts the gate up, it's actually pivoting the gate. So you can see in this illustration here, the gate is in the down position, and as the gate is rotated up, okay, it's pivoting on a center point here, and it lifts the entire gate panel out of the way. These gate operators and systems are generally built with the gate and operator together as a package so that the manufacturer can properly balance the weight of the gate and make sure that the attachment of the gate is correct. There's big springs inside that balance the weight of the gate, and that all has to be adjusted just right. Here, obviously, as this gate is lifted up, you want to make sure that you're considering any kind of overhead clearances from buildings, soffits, eaves, electrical power lines, phone, telecom, things like that. Sometimes I've made the mistake of walking a job and never looking up and then realizing, oh my gosh, I've got something very serious in the way of this project. Vertical pivot gates pose a tremendous shear danger, as you can imagine, when that gate is pivoting up. So that area that shear point has to be screened down to that 2 1/4 inch dimension, and that's an ASTM UL requirement. Now let's talk about barrier gates or parking gates, generally sometimes called parking or barrier. As you can see in this illustration here, this is a single arm application. So these are used for parking applications. They can be used for anti-tailgate applications, maybe synchronized with an iron gate, gated communities, toll booths, etc. Here we have an illustration of a barrier operator that is synchronized with an iron slide gate. So this can be used in cases where if we want higher security, we want one vehicle at a time, we want to eliminate the tailgaters, then we can have the barrier arm stay in the down position until the slide gate gets all the way open, and then the barrier arm goes up, allows the vehicle to go through, and then the barrier can come down. Because the barrier arm is so much faster than the slide gate, we can prevent multiple vehicles at a time. Arm assemblies for barrier gates depend on the gate size. Typically, single arm applications generally go up into the 14-16 foot range. That is model and make specific. Anything bigger than that is usually going to be a wishbone or a double arm assembly. These kinds of arm assemblies, depending on the make and model, can go into the up as far as 30 feet possibly. So gate hardware, very important element, quality gates, quality hardware. If it's a swing gate, you've got to use really good hinges. If your hinges are a metal on metal style, might work great for a manual application, but you've got to use a bearing style gate hinge. Lots of different weight sizes and capacities, adjustable ones, weldable ones, ones that can go from aluminum to steel for different applications. Slide gates also, we want machine wheels with sealed ball bearings. That's an absolute must, high quality. We want these gates to move and slide or swing very smoothly. So this kind of brings me to this idea of gate weight. You know, we think about, well, how heavy is the gate? The weight of the gate doesn't tell us everything. It's really the resistance to movement. And so when we talk about a slide gate, a better measurement of how much force or energy it takes to move that gate would be to use the term pulling force. And pulling force is the mass plus the drag. So mass, being the weight of the gate, is also compromised by the drag coefficient. So if we have a very heavy gate with really good wheels, then that pulling force is not nearly as much as if we had that same heavy gate with very poor wheels. So once wheels wear out, if they're not very good design, if they're not big enough, we might be creating more pulling force than necessary, and that puts more wear and tear of our operator, probably will wear it out, might cause other problems, of course. So to make a note, the pulling force of a typical 1 horsepower slide gate operator is probably around 185 pounds, maybe a little more. Some operators a little more stronger than that, 200, 250. Half horsepower is probably maybe about 2/3 of that, maybe 125 to 150 pounds. So that really means that if you can't move that gate by yourself, then don't expect the gate operator to do it very well or last very long. Fabrication. So a good panel is well constructed. We have UL and ASTM standards to meet. That tells us about things like sharp edges and protrusions and picket spacings and things like that. We also want to have a good operator attachment reinforcement. We want to plan out where our chain brackets might go and attach to, or where our swing gate operator arm might attach to. Most gates are made from chain link or from square tube steel. Of course, custom design gates can be made out of different materials, wood, wrought iron, architectural materials. Some gates can be screened with wire mesh or a perforated metal, expanded metals. Most gates use a picket infill to fill the interior of the gate panel. Regardless of the actual material used, the basic principles of gate design and installation apply to them all. So if we're talking about chain link, typically it's a galvanized product. Could also be a black vinyl coated product. The wall thickness varies and is determined by its schedule. So if you hear the term schedule 20, well, that determines the thickness of it. A schedule 20 pipe has a thinner wall thickness than a schedule 40 pipe. In the fence industry, pipe is always referred to by its outside diameter, where in the plumbing and electrical industries, pipe is referred to by its inside diameter. Because in plumbing and electrical, we're concerned about how much space there is inside to run water, liquids, or wire. But in the fence industry, everything is about the outside diameter. A clamp or a bracket has to fit around the outside of it. So in our fence industry, a 4-inch post has a 4-inch outside diameter. Here are some of the common pipe sizes used for the chain link gates and posts. Most gate frames in general are 1 7/8" and sometimes 2 3/8". Cantilever gates always use a top rail and a bottom rail. It's 2 3/8". That's designed to fit the cantilever wheels. That's a standard. Cantilever gate support posts or other gate posts are typically a 4-inch post and sometimes a 6 5/8". Those are common materials found in the fence industry. Square tubing comes in many different sizes and can be square or rectangular. Most common for gate frame construction would be a 2x2 tube steel probably with a wall thickness of a 125, that's 1/8 of an inch. Tube steel pickets for the infill are most commonly either a half or up to an inch. I think 1-inch pickets is probably the most common, and that probably has a thinner wall thickness of about an 0.625, which is about a 1/16 of an inch. Support posts are commonly a 4-inch square with wall thickness of 125, but sometimes a thicker wall for a heavier duty post could be up to a 250 or a 1/4 inch thickness. And of course, 6-inch square tube steel is also used and available, and typically probably in the 1/8 to 1/4 inch wall thickness again. Choosing the right layout. Every job site will have unique attributes that will dictate greatly the type of gate and layout. Be ready to alter as needed to better meet the performance, safety, and longevity of the project. So let's also talk a little about site previewing, and one of the things that can often be overlooked is power to the gate location. Is that being supplied? Yes or no? If it's not there already, who's going to do that? Give them the power requirements listed in the operator manual. Wire size and distance is one of the things that is commonly overlooked or underestimated in applications where someone else is doing the wiring. We expect the electrician, Sparky, to obviously follow code, and he does and will, but if we don't give him the exact specs for our operator and all of our loads, all of our stuff that we're running, then they may not have all the information they need to size the wire just right. If power is supplied and it's already there, well, what's the voltage? What wire size is there? What's the distance to the breaker? A common mishap is to go out and sell an upgrade from a 1/2 horsepower operator to a 1 horsepower operator and not consider the fact that the 1 horsepower operator now has a heavier current draw and the wire that is there may not be adequate for the new operator. Electrical power and or low voltage will likely be needed on both sides of the driveway. So who's responsible for this? If that's a lot of work, if you have to do a road crossing, it could involve a lot of trenching. It could involve maybe trying to bore a hole underneath the roadway, saw cutting, very expensive. Be sure to follow your NEC and your local jurisdictions or requirements for burial depths. Very important there. Residential road crossings typically require an 18-inch minimum cover, and a commercial roadway would typically require 24-inch roadway cover. So you can't just trench 6 inches across the driveway and expect to bury conduit and meet electrical code. Conduit sizes. In our industry, we're typically using 1/2, 3/4, 1 inch. These are the most common sizes. Larger conduits might be used for longer, more heavy-duty applications and different kinds of needs. How many conduits? Well, make sure that when you're doing a road crossing, you need at least 2 conduits put in, one for high voltage, one for low voltage. The standard says, and the electrical industry always says, separate high voltage from low voltage. Mark the location with the customer. Use a stake or rebar. Mark the layout with marking paint. All these things have to be set and marked out so that you can call for locate. Very important thing to do before you dig. You don't want to be digging in the ground with not knowing what kind of utilities, water, electrical, gas, a variety of things. It can be very dangerous and very costly if you hit them. Phone service. So that's another important thing to consider. If it's a commercial job, is it a dedicated line? Does this require service to be ordered from the phone company? Nowadays we have a lot of cellular systems, so that's less of a concern. If you're going to sell a cellular driven unit, then this is going to be taken care of. But if we're going to utilize the actual phone company's phone service, then that needs to be determined. And where would that originate from? You can't just go to the local corner post where you see all the phone lines coming for the phone company. They have to come out and establish a demarc or an actual service point for you, and then from there it'll be your responsibility to trench and pull wire from that demarc out to your gate pedestal. If it's residential and it's shared line, then that typically will require cabling all the way back to the house where the house demarc is at. If your customer is no longer using a landline, but they want to use a hardwired phone as an intercom, you can still use probably the same buried cable if that exists, and wire so. If not, you'll still then have to put in a proper phone type cable and run it to the house. Types of phone service: standard, so it's a voice only POTS line. POTS lines, of course, that stands for plain old telephone service. Less common these days, but it still does exist, and there are phone systems that utilize that. It could also originate from a cable or a VoIP, so that's a voice and data. So if the customer has a Comcast service to the home, then any voice is going to be using the VoIP from the high-speed internet access that the Comcast service is providing. And then the other option could be cellular. Now let's cover some fire department requirements, and this is another area that can be easily overlooked. This is going to be determined by the local fire department, and it's best to go to the local fire department for any given job and find out what their requirements are. Just walk in and ask them, tell them you're doing an automatic gate system at such and such address, and you want to know what their requirements might be for that site. Those could include lane width restrictions. Many fire departments will have a width restriction, so you have to meet a minimum width. You don't want to underestimate what that might be, otherwise you'll be forced to do some very expensive rebuilding of roads, gates, columns, etc. It also will involve the entry device requirements. This may require either a Knox box, a lock box, could require a fire strobe, or maybe a click to enter, a variety of different devices depending on the application. If it's a simple residential single home, they may not have any requirements at all, but you'd at least elect to use a Knox box, Knox key switch that is. But they may have restrictions or requirements for a fire strobe if it is a multi-resident application. They might have a requirement for battery backup or have very specific manual operation requirements. Extraordinary site weather requirements. Another thing that sometimes is easy to forget. So does the site have severe wind? That could really impact how we decide to design the gate or not design it in terms of windage. It'll also impact the gate operator and other elements. What about severe cold? Do we need to have any kind of heater equipment or other elements into it? Severe heat could also be an issue. Security. Do we want to have locking mechanisms, mag locks or solenoid locks? The security of the system might be very important for the customer, and so additional methods will need to be employed. So now that we've talked about many job preview elements, I've included this slide as an example of a checklist that is very useful for previewing a job and identifying the things that are going to be included in that job. This can be used as an intro to discussing what the customer needs are. It could be used to base your quote off of, and in the end, when the job is installed, is an excellent form to fill out to verify and document exactly what's on that job and put it into your job file. So this one here is specific to slide gates. It talks about the gate operator make and model, accessories being used, hardware, what kind of other cantilever details, V-track, tube steel, what's the electrical power on site, what's the distance to the breaker panel. These are great things to be able to get that information down when you're previewing the job. And then this one here is specific for swing gates. Well, thank you for viewing this video. Stay tuned for the next episode and the next chapter. Good luck and good installing.